Hi, my name is Nakshatra Nadar. This is my design and analysis of algorithm CI1. My row number is 81, division B. This is the first FKB problem. Here weight, which is 12, 2, 1, 4, 7, 6, 10. Profit 6, 4, 2, 1, 2, 10, 8. And weight and capacity is given, which is 25. The find optimal solution. Step 1. It is one of the variation of classic step set problem where we are allowed to take a fraction of items rather than choosing entire item. Goal of the FKB is to minimize the total value, which is profit. For a given problem, number of item is given, value, profit, weight, ratio and capacity is given. Step 2, we have to compute the ratio, profit and weight. So here the items are given. These are the weight value, this is profit value, and by using the formula we have calculated this one. Now moving into the step 3, we have to sort it into descending order of R, which is ratio. These are the items and these are the weight, profit and ratio, which has been computed into the descending order format. Then moving into the step 4, consider I is equal to 2, item 2. Then 25 is greater than 2, remaining capacity 25 minus 2 is equal to 23, which we have taken from this one. Profit plus 4. The last one is 4, the profit is equal to 4. Consider I is equal to 3, item 3, which is greater, 23 is greater than 1, remaining capacity 23 minus 1, which is 22. Then the profit value is equal to 4 plus 2 is equal to 6. Consider I is equal to 6 by repeating the same steps back to back. Item 6 is less than 22. Remaining capacity 22 minus 6 is equal to 16. Profit 6 plus 10 is equal to 16. Then next, consider I is equal to 7, item 7. Then 10 is less than 16. Remaining capacity 16 minus 10, which has 6. And then profit 16 plus 8 is equal to 24. Then the last one, consider I is equal to 1, item 1. 12 is not greater than 12 is not less than 6, which has been false. Remaining capacity 6 minus 12 is equal to 0. Profit 24 plus 3 is equal to 27. Step 5, the optimal solution of FKB using GM are 27. The FKB item set is 6 into 12, 1, 1, 0, 0, 1, 1. Next page is Prime's algorithm problem. These are the nodes connected to each other by the minimized format. Step 1, MST. It is a subset of all the edges of a connected undirected edge weighted graph that connected all vertical together. Second one, GM. It is the problem solving approach that makes the locally optimal choice at each stage, which the hope of finding of a global optimum. Prime. It is the method that starts with a single vertex and repeatedly adds the smallest weighted edge that connects a vertex in the growing spanning tree to the vertex outside of it until all the vertices are included. Then moving into the step 2, here manual tracing of Prime's algorithm, where I is considered as iteration, J and K are vertices, and these all are the nodes, and helping node and min cost node. Here I will explain the first one, where is A, which is A and B. Because why A and B? Because there are a minimal nodes here. Then C is considered as B, D is considered as A, and E is considered as B. And A, B is considered as minimum node, which has been 1 mini cost. Then moving into the step 3, generate mini cost spanning tree using the Prime's algorithm periodically. Here is the iteration 1, which is A and B, where it is shown here A and B. and then second one is A node connected to B and B node connected to C. And iteration 3, A node connected to B as well as D and B node is connected to C. Iteration 4, A node connected to B, B node connected to C as well as A node connected to D and D node connected to E. Iteration 4, A, B, C connected to each other, A connected to D, D connected to E and E as well as connected to G. In iteration C, the G is connected to F. The final diagram has been shown here. The cost of the MSG, the final answer is 17. Dynamic design algorithm paradiagram. Dynamic programming is a design technique used in the algorithm where a problem is divided into small sub-problems and the result of these sub-problems are stored, reused to avoid solving the same problem again. Main features: divide the problem into sub-problems, store answer of sub-problem that is in the table or in the memory, reuse the stored answer whenever needed, build the final solution step by step. When to use a DB, which is dynamic programming, problem has overlapping sub-problem, same sub-problem appears again and again, problem has optimal substructure, best solution can be built from smaller best solution. There are the example which is Fibonacci sequence, shortest path problem, the stack problem, matrix chain multiplication. Thank you.